Topic 6. Groups in the periodic table. Group 7. Introduction. So here is the periodic table, and this time we'll be looking at halogens, which is group 7 of the periodic table. Now all group 7 elements have similar chemical properties. Group 7 goes from fluorine, chlorine, bromine, iodine to astidine. Now, the thing that group 7 elements all have in common is their electronic configuration. They all have 7 electrons in their outer shell. This can be seen in the diagram here. Now, as we are aware, elements want to have a full outer shell. So for halogen atoms, it is easier for them to gain 1 electron than it is for them to lose 7. So when they gain 1, they will fill this outer shell. Now you may be asked to link back to previous topics and to draw a dot and cross diagram for chlorine. So chlorine is diatomic and exists as Cl2. Now this is how chlorine gains that extra electron. So when it pairs with a neighbouring chlorine, you can see it now has a full outer shell, as they are sharing a pair of electrons, and this gives it a covalent bond. So this explains why chlorine, and indeed all of the halogens, are diatomic, due to this shared pair of electrons giving it a covalent bond and therefore filling the outer shell of electrons. Now halogens have quite distinct properties. Now as you move down the group, the melting and boiling points increase. Now this can be seen with the state, the chemical state of each of the different elements. So chlorine is a gas, bromine is a liquid, and iodine is a solid. So obviously everything below iodine would also be a solid. Now you'll notice fluorine is missing from this table as well. Fluorine is also a gas, because fluorine is above chlorine. Now, so as you go down the group, they have increasing melting and boiling points. The density also increases, so this makes sense as well. If we're going from solid to liquid to gas, we would therefore expect them to be more densely packed together, the particles. The 3 listed here, chlorine, bromine and iodine, also have distinct appearances, and for the GCSE specification at Excel, you must be aware of their appearance. So chlorine exists as a greeny yellow gas, bromine as a brown liquid, and iodine as a purple black solid, and you can see that in the diagram here. Now you could be asked to predict the trend, so use this trend to predict the properties of another element below iodine, and in this case that would be astatine. So, as we know, the melting and boiling points are increasing, they're becoming more dense, and they're becoming darker. So we would therefore expect this to continue. We would expect astatine to be solid, to have a higher melting and boiling point than iodine, and indeed for the colour to be darker, which is the case. You can see from the diagram here. Now we must explain, using the electronic configuration, why the halogens react in this way. So it is easier for halogens to gain this 1 electron. So with chlorine, when we gain an electron, we go from a chlorine atom to a chloride ion. But comparing the configurations, we need to explain why the reactivity varies between the halogens. So when we look at this, we can see there are a few distinct differences. And if you were asked to pick out which was the most reactive, your eye should be drawn to fluorine. Now fluorine is the most reactive halogen, and the reason for this is due to the nucleus. Now as you're aware, the nucleus contains protons, and these are positive. Now this positive charge will draw in the negative electron. So if there are more shells, the positive is further away. There's a weaker attraction for this electron it's trying to attract. So with fluorine, it's nice and close, pulling that in. With iodine, much further away, weaker attraction. So here that is explained in bullet points. As you move down the group, elements become less reactive. It's harder to attract the electron, as outer electron shell is further away from the positive nucleus. Now halogens react very similarly with metals. Now the nature of their reactivity, some will react more vigorously than others, but what they produce during a reaction is the same. So a halogen will react with a metal to produce a metal halide. So for example, sodium will react with chlorine gas to produce sodium chloride. And you can see the balanced equation here as well. We need 2 sodiums to react with chlorine gas to produce 2 sodium chlorides. Halogens also react similar to one another when reacted with hydrogen. When they react with hydrogen, they form an acid solution. So a hydrogen with a halogen will form a hydrogen halide. An example of this would be hydrogen and chlorine gas. This would form hydrogen chloride, more commonly known as hydrochloric acid. The balanced equation for this would be H2 plus Cl2 becomes 2 molecules of hydrochloric acid. And this same reaction would occur whether you were looking at chlorine, fluorine, bromine, iodine or acetylene. You would still get the hydrogen halide. Now the reason it's an acid solution, you would be able to test for this using a pH probe or universal indicator. So the hydrochloric acid produces the free H plus ions, and these give it a low pH value, which makes it acidic. Now let's look at chlorine in a little bit more detail. So chlorine has a number of uses. Chlorine is primarily used to kill bacteria. So we see it used in bleach and in swimming pools. So it's used here to kill bacteria in the water. But chlorine, when it's produced in a reaction, we need to be able to test for it. It is toxic to humans, so often we need to be cautious of when it's produced. So we can use this chemical test to see if it's produced. What we would do is we would take a piece of blue litmus paper and we would damp it with some water. We would then hold it over the chemical reaction, and the gas, if chlorine was present, would first turn the damp blue litmus paper red, and it would then bleach the litmus paper. So the litmus paper would become white if chlorine gas was present.